Hello everyone. Now that we have a good understanding of the tangent function graphs, we are going to move ahead to learn about the cotangent curves. Y equals cot of x is the cotangent function. We are going to talk about the properties of the cotangent graph and also study its shape and behavior. To begin with, the period of the cotangent graph is pi, which is the same as the tangent function. The domain, which represents all possible x values that can be input into a function, which would give us a real number as an output, would be all real numbers except integral multiples of pi. The asymptotes of the graph will be at the integral multiples of pi. What do we understand by the integral multiples? It means pi multiplied by integer values, be it positive or negative. So pi and then 2 pi, 3 times pi, 4 times pi, and so on the positive side. On the negative side, negative 1 times pi, negative 2 times pi, negative 3 times pi, and so on. Whenever pi is multiplied by an integer value, positive or negative, it's referred to as the integral multiples of pi, and the asymptotes of the graph will exist at those integral multiples. That means at those x values, the graph will reach positive infinity or negative infinity. The range of the function is all real numbers. The range refers to the y values that can be output from a function. We have here a picture of 3 cycles of the cotangent graph, but let's focus on just one cycle, the cycle which is between pi and 2 pi. We see this dashed vertical lines, which are the vertical asymptotes of the cotangent function, one at pi, the other one at 2 pi. The one at pi is the left-hand side asymptote. The one at 2 pi is the right-hand side asymptote, within which the entire cotangent function will exist. As we move from the right-hand side towards the left side asymptote at pi, we see the y values increase first slowly and then rapidly. As we move from the left-hand side towards 2 pi, the right-hand side asymptote, we see that the y values drop first slowly and then rapidly. And this is the shape of the graph, which is the same as the tangent function, but it is kind of a reflection of the tangent function. It's a vertical reflection. All right. So in the next slide, we will learn about some more characteristics of the cotangent curve, and then we'll go on to the steps we must follow in order to draw the cotangent graph, which is going to be pretty similar to what we learned about the tangent function graph. Here are the steps to graph the variations of the cotangent function. The form of the variations can be represented in this equation y equals a times cot of bx minus c, where b is greater than 0. This is again similar to what we learned when we were studying the tangent function. Instead of the tangent here, we have the cotangent. The first step is to find where the asymptotes would be located. Find 2 consecutive asymptotes by finding an interval containing 1 full period. The asymptotes would be at 0 and pi for the basic cotangent function. If there are variations, then we are going to find the x values using this expression, 0 less than bx minus c less than pi. We have to solve for x here to get the location of the left-hand side asymptote and the right-hand side asymptote. Recall that for the tangent function, it was negative pi over 2 on the left-hand side and positive pi over 2 on the right-hand side. For the cotangent function, it's 0 less than bx minus c less than pi. A pair of consecutive asymptotes occur at bx minus c equal to 0. So we can find the left-hand side asymptote by solving for x in this equation bx minus c equal to 0, and the right-hand side asymptote by solving the equation bx minus c equals pi. The next step is to find the x-intercept, which would be located midway between the consecutive asymptotes, the same as what we learned for the tangent function. The third step is to find the points on the graph 1/4 and 3/4 of the way between the consecutive asymptotes. So those values would have y coordinates of a and negative a respectively, whatever this value of a is in the equation. We have to, of course, find the corresponding x values, the value which is 1/4 way from the left-hand side asymptote as well as 3/4 way down from the left-hand side asymptote. And finally, in the fourth step, we are ready to draw our graph using the information we found in the first 3 steps. All right, here's a pictorial representation of the steps of graphing the variations of the cotangent function. We begin by finding the location of the 2 vertical asymptotes. On the left-hand side, we can find the location by solving the equation bx minus c equal to 0. We solve for x. Whatever value we get for x is where the left-hand side asymptote will be located. For the right-hand side vertical asymptote, we solve the equation bx minus c equal to pi. Once we solve for x, we will be able to get the location of the right-hand side asymptote. The second step is to find the location of the x-intercept, which will be right midway between the 2 asymptotes. So here we have step 1, which represents finding the vertical asymptotes. Step 2 would be to find the x-intercept, which is right midway between the 2 asymptotes. The third step is to find the x and y coordinates 1/4 way from the left-hand side asymptote as well as 3/4 way down from the left-hand side asymptote. So 1/4 way from the left-hand side asymptote would be somewhere here. We have to find the x value as well as the corresponding y value. For 3/4 way from the vertical asymptote on the left-hand side would be somewhere here, and we have to find its x and y coordinates. The y values would be positive a 1/4 way down, and 3/4 way down the y value would be negative a. Given those values of y, we should be able to find the value of x. And then finally, in step 4, we are ready to draw our graph. So finding the x and y coordinates 1/4 and 3/4 way from the vertical asymptote represents step 3 in the process of graphing the variation, right? Here's an example of graphing a cotangent function variation using the steps that we just learned. The question says graph y equals 1/2 cot of pi over 2 times x. So we have to put it in the form that we just learned, which is y equals a times cot of bx minus c. That is the form of the variation of the cotangent function. However, we need to identify the values of a, b, and c. So over here, if we put this equation in that form, a has a value of 1/2, b would have a value of pi over 2, and there's no minus c over here. correct? There's no minus sign after the bx. Therefore, c is going to have a value of 0. So here we go. We have a equals 1/2, b equals pi over 2, and c is 0 because that doesn't exist in this equation. The next step is to find the location of the asymptotes of the graph. And we do that by solving the inequality, which is 0 less than bx minus c less than pi. Once we solve that, we substitute bx minus c with pi over 2 times x, and we solve for x. So I'm going to do that on the side before I pull up the answers. All we do is pi over 2x equal to 0 is one of the equations, which will give us the location of the left-hand side vertical asymptote. So pi over 2x equal to 0, therefore x is going to be 0. 0 divided by pi over 2 will give us 0. The next one is pi over 2x equal to pi, correct? This value here. Therefore, x should be pi times 2 divided by pi. In other words, pi divided by pi over 2, which is pi multiplied by 2 divided by pi, is going to give us x equal to 2, and that's where the right hand side vertical asymptote is going to be located at. So when I pull up the solution, it says 0 less than x less than 2. That is how they came up with the location of the left hand side and the right hand side vertical asymptotes by solving the equation for bx minus c equal to 0 and bx minus c equal to pi. The next step is to find the coordinates of the x-intercept, which would be midway between the consecutive asymptotes. So the asymptotes would be located at 0 and 2, and the x value midway between 0 and 2 is 1. So x equal to 1 is midway between x equal to 0 and x equal to 2. Therefore, the graph passes through 1, 0. It will cross the x-axis at 1, 0. So step 1, we found the two consecutive asymptotes, an interval containing 1 period for this variation of the cotangent graph is 0, 2, and that is where the vertical asymptotes would be located. And then we found the location of our x-intercept, that would be at 1, 0. We will go ahead to find the coordinates 1/4 way from the left-hand side vertical asymptotes and 3/4 way down from the left-hand side vertical asymptote next. In step 3, we will find the coordinates of the points 1/4 and 3/4 of the way from the left-hand side vertical asymptote of the cotangent function graph. We know the y values can be derived by looking at the value of a in the function, which is y equals 1/2 cot of pi over 2 times x. So in this equation, the value of a is 1/2. Now 1/4 of the way from the left-hand side asymptote, the y coordinate will be a positive 1/2. So y value will be a equals positive 1/2, and 3/4 of the way from the left-hand side asymptote, it'll have a negative a for the y coordinate. So I'm going to write here y equals negative a, which is negative 1/2. How do I know which one's going to be a positive and which one's going to be a negative value? If you recall the shape and the behavior of the cotangent function, we have the two asymptotes left and right in this figure here, and a midpoint between the two asymptotes is here. When we move from the midpoint towards the left-hand side asymptote, the y values increase. So this is the shape of the graph. Between the midpoint and the vertical asymptote to the left, the y values increase and go up all the way to infinity. As we move from the midpoint towards the right-hand side asymptote, the y values fall. They drop. They are below the x-axis, so the shape of the graph looks like this. Therefore, 1/4 way, which would be between the left-hand side, which would be right in the middle of the left-hand side asymptote, and the midpoint somewhere here would have a positive y value, whereas for 3/4 way down, which would be probably a value here, somewhere between the midpoint and the right-hand side asymptote, it would have a negative value for the y coordinate. Once we have the y coordinates, we need to find the corresponding x values and come up with an ordered pair. We do that by substituting the y coordinate values into the given equation and solve for x. We are going to start by solving for the x value when y equals -1/2. So over here we see that we substitute -1/2 into y into the equation, and we end up with -1/2 equals 1/2 times cot of pi over 2 times x. We have to solve for x, therefore isolate cot of pi over 2x by dividing both sides by +1/2 to get rid of this half here. When we do that, we end up with -1 on the left-hand side. -1/2 divided by +1/2 is -1, and we are left with cot of pi over 2 times x on the right-hand side. Now at this point, I want to remind you, if we go back to the basic cotangent function and the special angle value ratios, then cot of 3 pi over 4 would have a -1 for its ratio. You have to think about what angle would have -1 as its ratio. It would be 3 pi over 4. In other words, the angle for which the cotangent ratio would be -1 is 3 pi over 4. I can equate pi over 2 times x with 3 pi over 4 and solve for x. What we come up here is 3 pi over 4 equals pi over 2 times x. We've just equated this expression by 3 pi over 4 because we know that cot of 3 pi over 4 gives us a -1. And when we solve for x, we get a value of 3 divided by 2. There's no pi associated with the x value because when we divide both sides by pi over 2, the pi is eliminated and we end up with 3 over 2. So 3/4 of the way from the left-hand side asymptote, the ordered pairs would be 3 over 2 for x and -1/2 for y. Now we have to find the x coordinate when y is 1/2, that is 1/4 way from the left-hand side asymptote. It's the same process, except we substitute y with +1/2. Then we divide both sides by 1/2 to isolate cotangent. We end up with 1 equals cot of pi over 2 times x. But this time, which angle would have a cotangent ratio of +1? That is pi over 4. Cot of pi over 4 is equal to 1. So we can equate pi over 2x with pi over 4, which will give us a ratio of 1. And then we can solve for x. So pi over 4 equals pi over 2 times x gives us an x value of 1/2. So the coordinates of the point 1/4 way down from the left-hand side asymptote would be 1/2, 1/2. And that is exactly what they came up with. The first ordered pair is for 3/4 way down, and the second ordered pair 1/2, is for 1/4 way down from the left-hand side asymptote. In step 4, we are ready to sketch the graph using the information we found in the previous steps. We start by drawing the asymptotes of the graph. In step 1, we found that the asymptotes would be at x equal to 0 and x equal to 2. X equal to 0 is the y-axis, and that's the left-hand side vertical asymptote, and on the right-hand side the asymptote would be at x equal to 2. The midpoint between 0 and 2 is 1, and that's where the x-intercept of the graph would be. So this point here will have coordinates 1, 0. Then 1/4 of the way from the vertical asymptote on the left hand side would be somewhere here between 0 and the midpoint. Let's say it's somewhere here. That would have coordinates 1/2, 1/2. So if we draw a line up to the curve, then it reaches to about 1/2 distance from 0 along the y-axis, and 3/4 of the way would be somewhere here perhaps, and that would have coordinates 3 divided by 2 for the x value and -1/2 for the y value, and we do see that the y value is a negative value. It's below the x-axis, right? So this is the final picture of the graph, which is y equals 1/2 times cot of pi over 2 times x.